Chapter 19, we're going to do some climate disruption. The beginning of this starts off with a case study on Greenland, and the biggest things to remember about this is Greenland is basically covered by glaciers, contains a large amount of the world's fresh water, and more or less, scientists have seen that these glaciers have been retreating at a fairly rapid rate. Kind of one of the things with climate change is looking at what's going on, and if that continues in that same direction over the next whatever century, then they kind of base their predictions on these things. Couple that with potentially things becoming even warmer and this increasing, and then you kind of get the idea of why there is concern if all of this ice were to melt. So first piece is looks at how is the Earth's climate changing? Not necessarily now how is it changing, but how has it changed in the past? So, in looking at the past, at least the evidence that scientists have, they've seen that there's been periods of up and down, and they take a very long time for the Earth to cool or the Earth to warm. Uh, Little review: weather, climate. We focus mainly on climate in this chapter. We're looking at not necessarily how are things going to change day to day, but how are they going to change in the big picture. And really not necessarily how they're going to change, but that temperature change and what that may do to the Earth in terms of what we do end up seeing on a day to day basis. One thing that scientists know is that the Earth has changed based on rock, sedimentary rock fossils, layers, and certain things they can determine from that compared to what's going on in things like ice cores, where you get certain gases trapped and you get a rough idea of what the Earth's atmosphere was like. That's broken into certain strata as well. They've kind of figured that there's been ice ages and interglacial periods all throughout the Earth's history, but more accurately, they can see these things over the last 900,000 years. Recently, okay, we're in an interglacial period, meaning that things are thawing out, so to speak, and the temperature is expected to be a little bit warmer than times in the past. Over the past 1,000 years, the temperature's been fairly stable, and the big concern when it comes to climate change is how quickly things have changed over the last 40 years or so. This is an image we saw in class, but this is 900,000 years. So realistically speaking, this would be stretched out a whole lot more. And these periods of time would not look quite as quick as they are. So, if you look at something here, for example, from this peak at about 100,000 to this peak at, if we had to estimate, 175, you're talking 75,000 years for this to happen. Now, the past 130 years, even though it hasn't even been 1 degree Celsius increase. However, compared to this and what you're seeing, if we look at just maybe this period from 12 to 13 point something, we're talking about 50,000 years it took for this to happen, to go up from maybe a little below 12 to 14. So to see this happen as quickly as it has is concerning. We talked about the ice cores, so they actually drill down. They pull out these ice cores, and the ice stratifies similar to the soil in that you get these distinct layers, and in those layers you get some things trapped or captured that kind of tells a little bit of a story. You get gases trapped. You can sometimes get things like pollen, that type of stuff, dust. Any particles in the air are going to be trapped in this ice, and that gives you a little bit of a clue as to what things were like. Why is it climate changing? So this is a kind of a two-part answer. Number one, it's changing because that's just what it does. The biggest thing is that the rate has increased, or scientists believe the rate has increased, not only since the Industrial Revolution, but even more recently in the last 40 years. Greenhouse effect we've talked about. So the whole idea of climate change is based on the greenhouse effect and those greenhouse gases that currently sit in the Earth's atmosphere. These gases, okay, so as sunlight comes in, some of it's deflected. Some of it's absorbed into the surface of the Earth. Some is deflected before it ever gets here. Some is absorbed, and then other is emitted, okay, as infrared radiation it leaves. Well, these greenhouse gases kind of redirect that radiation, with some of it coming back towards the Earth, some of it going to space, basically going in all directions. With climate change, global warming, we're talking about an increased, and really when we look at the atmosphere, we're talking here a lot closer to the surface of the Earth. But we're talking about a significant increase in these gas molecules that are redirecting a lot of this heat, with obviously some of that coming back towards the surface of the Earth, thinking that a higher concentration is going to reflect more of that heat back towards Earth. This is just lifetimes of the various gases in the atmosphere. You can see that, and like most things, when we put them in the atmosphere, they can last for extended periods of times. I mean, these things also occur naturally. So, when we look at these things, the biggest thing is if we're overloading it, if we're putting excess, it's going to take a while before that sort of cleans itself out or regulates itself or comes back to what would be considered normal. Warming potential. So even though carbon dioxide is the most concentrated of these three in the atmosphere, these two actually have a greater warming potential. So the greatest potential to keep or hold that warmth in the atmosphere. Scientists believe human activities are playing a key role in this whole warming deal. So these things we can measure now, especially since the Industrial Revolution. We can measure outputs of these things. We can measure their concentration in the atmosphere. So basically what they've said, or scientists have said, is we've tracked these things, in particular these two, CO2 and methane. We know where they come from. We also know that looking at the past, there's a correlation between these gases and a rise in temperatures. So these predictions aren't just based off of a guess. To some extent, yes, but they're also based off of scientific evidence and the gases they've seen trapped in ice compared to what they see going on the land and the types of pollen they're finding in the ice, that type of stuff. These graphs show CO2 concentration in the atmosphere. We've measured it right at or near 400. You can see historically, scientists don't believe it's ever been that high. That being said, we're also analyzing gas trapped in ice, so that has to be considered, when you see these numbers. Could there have been a time when it was as high as it is now? Absolutely. Okay, but we hadn't seen it in recorded history prior to this time, and you can also see how quickly that's happened. And these are temperatures. So scientists believe the temperature has gotten as high as it is now. But again, they don't necessarily know exactly what that meant for the Earth or for the planet. And obviously, there weren't people here that we know of. So it's a little tricky. This is just looking at CO2 levels and average temperature over the last 130 years. You can see there is definitely a correlation. All right, so a couple other pieces of human activity. The average atmospheric concentration of CO2 has gone from 280 to 400 parts per million since the Industrial Revolution. We know that humans are the major contributor of excess methane. And we know that certain countries generate more emissions than others. The US, just because we have so many people, vehicles, that type of stuff. China, because they're really starting to develop and spread a little bit of that wealth across their country. So they're getting more and more people that are contributing to this. The sun, some researchers thought, well, maybe the sun's just putting out more energy, or it's getting warmer, whatever the case might be. Scientists have said if the sun were getting warmer, we'd see the entire atmosphere getting warmer. But that hasn't been the case, especially since 1975. So the troposphere is warm, but the stratosphere is actually cooled off. If it were the sun, you would see this, roughly increasing about the same amount. Also, this is kind of an indication that maybe more of the heat is being trapped closer to the Earth and not making it here. Oceans, we talked a little bit about ocean acidification, but biggest things with this is warmer oceans absorb less carbon dioxide, and the more carbon dioxide oceans absorb, the lower the pH, which is going to highly impact a lot of the organisms here.